Hello and welcome back. In this video, we are going to discuss recursions. Many times we need to repeat the tasks several times, right? So there are two approaches to write repetitive algorithms. The first approach is the iterative approach. So in iterative approach, we repeat the code multiple times, and typically to repeat the code several times, we make use of the looping constructs, right? Now, recursion is the repetitive process in which an algorithm calls itself. To write recursive algorithms, we must learn to think recursively. So, this is really very interesting. So, let's see one example, right? How will you define a list of numbers? So, we may say that a list is one or more numbers separated by commas, right? Usually, we write the list like this, right? So, we may say that a list is one or more numbers separated by commas. An alternate equivalent definition, which is recursive, can be written like a list is a number or a number comma list. So we are defining the list in terms of itself. So we defined the list with recursive definition like a list is a number or a list is a number comma list, right? So the recursive definition defines each of these lists, right? So list is a number comma a list, right? Then once again, if we consider this list, then it is a number comma this list and so on. So let's see how to trace this recursive definition of the list. So let's consider this very first example having four elements 24, 88, 40 and 37. So initially this is a list, right? Now this list can be decomposed like it is a number comma list, number comma list. So here number is 24 comma and rest of the numbers in the list will form another list, right? Now once again, this list can be decomposed as a number comma and a smaller list than the earlier one, right? So number comma list, and the process continues till in our list we have only one number. So whenever only one number is there, then this particular definition will satisfy. So a list is a number, right? So this is how recursively written or recursively defined list can be traced, right? So if you look at this particular recursion, you may say that each time we are reducing the size of our list, right? Now, once again, referring to our definition, recursive definition of the list, a list is a number or a number comma list. What we note is this definition of the list contains one option that is recursive and one option that is not recursive. So this is the recursive part of our definition, whereas this is non-recursive part of our definition. Okay, so the non-recursive part of definition is called as the base case, right? So in this definition, this non-recursive part is the base case. So without a base case, the recursion would never end, right? And it would be a problem that is referred as having infinite recursion. So always we should have a base case or a non-recursive part of the definition. Then only we can come out from the recursion, otherwise it would be infinite form of recursion. Let's see one example in mathematics, simple example, and that is computation of factorial of a number. So the factorial of a positive number is the product of integral values from 1 to the number, right? So if we want to write the iterative definition of factorial, then how we are going to write it? See here, a repetitive algorithm is defined iteratively whenever the definition involves only the algorithm parameters and not the algorithm itself, right? So this is the iterative definition. So factorial of n is given as 1 if n is 0. If n is greater than 0, then it is n into n minus 1 into n minus 2, so on up to 1, right? And that is why we said that a repetitive algorithm is defined iteratively whenever the definition involves only the algorithm parameters and not the algorithm itself. So here, what is the parameter? N is the parameter. So that parameter appears in the definition, but not this algorithm is present in the definition. So factorial of 4 can be computed as 4 into 3 into 2 into 1, and the result is 24. Now let's see this recursive definition of factorial. So the algorithm appears within the definition in case of recursion. The algorithm appears within the definition, right? So see here, factorial of n can be defined recursively now, like 1 if n is 0. If n is greater than 0, it is n into factorial of n minus 1, right? So this is the algorithm that once again we are calling as a part of the definition, and that is why this is recursive definition. So if you look at this particular recursive definition, you can see here that in the definition we are reducing the size of the problem. So initially we were computing the factorial of n as a part of definition. Now we are computing the factorial of n minus 1, right? And the recursive definition will continue. So if we want to find factorial of n minus 1, then what we will do? We will write this factorial of n minus 1 as n minus 1 into factorial of n minus 2. So once again we are reducing the size of the problem, right? So this is how we define factorial function recursively. So with this, we are going to conclude this video on recursion. Thank you and happy learning. In next video, we'll see factorial in more details.